So hello everyone and welcome to the Dapper community call. This is March 23rd. Thank you for joining live, and if you're catching this on YouTube, thank you for watching this. So as part of our efforts to diversify the co-hosts, or actually the host of the Dapper community call, we will be rotating between different hosts from the Dapper maintainers and maybe even community members. And so I want to thank Ori for doing this until now. Ori will be back. He's not gone. So thank you, Ori, for taking all of the community call efforts on your shoulders up until now. And like I said, Ori will be back, but I think this is an appropriate time to thank you for what you did. Today, I will be your host, and let's get going. So this is the agenda for today. And we're gonna start off with a really awesome session from George Stevens, who's gonna talk to us about the Dapr-Mesh, gRPC, and PubSub. And we've got some slides and a really nice demo. And then we're gonna hear from Maxime Kim from Microsoft about Dapr and Azure API management. We will then spend a little bit of time talking about the Cncf donation process, and that's just gonna be presented by us, the Dapr maintainers. And then lastly, we have a few additional insights about the 1.0 release from Ori Zohar. We will then head off to an open discussion. So the title for our first item on the agenda was a bit longer. It was thinking outside of the Dapr-Mesh box with gRPC and PubSub, but I needed it to fit into the slide. So I shortened it a little bit. My apologies, George, but the floor is now yours. Feel free to start sharing your screen.
Okay. Okay, can you see it?
Yep.
Okay, let's get this magnified and start the slideshow. So, a couple months ago, I spent a number of weeks trying out a bunch of Dapper components with gRPC services with Visual Studio and C#. And one of the components I tried out was the PubSub to various places. One of the places was the Azure PubSub. And in doing so, I thought I was running this all on my one machine. I have two services and a test client, service A and service B. And I was PubSubbing from service A to service B. And I thought, wow, I wonder if this could run on two machines. And in order to do that at the time, I would have had to install a version of Dapper on my other backup dev system, and it just was too much trouble. I said, I'm going to wait till version 1 comes out. Well, version 1 came out, and a couple of weeks later, I had enough time. And so I installed Dapper 1.0 on my spare system and just copied Visual Studio over there, and started up service A on one system and started up service B on the other system, and published a bunch of events, and it worked. I mean, there was no code changes, nothing. It just worked. And so that got me thinking about, I had been thinking just in terms of one mesh. And I thought, well, maybe we should think in terms of more than one mesh. So let's go ahead and see what is a mesh first. And all it is just a collection of collaborating services within a nearby network of Dapper sidecars. And so there you can see, that's just a diagram of what it looks like if you look at all the possible connections. And we know that the sidecars know about each other because of multicast DNS, or on Kubernetes, it has its own DNS. And so why would one want to think outside the mesh? Here, the mesh is a nice little orderly collaboration of services. What's outside? What's in it for us to look outside? Several things. Number one, it helps to think at a high conceptual level about the services themselves and forget about the technical details, because that can add a lot of clutter to your mind. And so at the bottom, you see a screen that just shows this little test sample that I have. It's just a really clean setup where it's got the services that do the behavior and the utility in Magenta that is pub sub, and that doesn't say anything about hosting, anything about Dapper, anything about technologies, anything about gRPC. It's just you could do this anywhere. So that's our logical diagram, and that's a really good reason to think outside the Dapr-Mesh and just focus on the job your services has to do and the collaborations they have. So another way, a reason to look outside the mesh is so you focus on communications with external services, especially those that you own. Because when you have an external service that you have to utilize or connect with, then you have to ask, do I need another Dapr-Mesh to contain that? Because multicast DNS and Kubernetes DNS only goes so far. It doesn't work too good when you have big geographical differences. That's the other reason to use multiple meshes, is when services are geographically separate. A third reason is when one Dapr-Mesh becomes so filled up with services and their intercommunication with each other is that it becomes unmanageable. And so that looks like this. This is what is unmanageable. We have mathematics working against us. So if you think of down here on the x-axis as the number of services, if we have 10 services there, you can see we've got, about 45 interconnections. And if we've got 20 services, yikes, it goes up to like 190 interconnections. And so this curve can be a real killer. Even if you reduce the connections by 50%, it's still exponential. Maybe even if you reduce it by 75% by disconnecting services from each other, it still has exponential characteristics. So at some point, we don't know where, we hope we're not going to have to spend a lot of time trying to figure out all these connections between all these different services. So that in and of itself is a good reason to say, okay, is it time to create another Dapr-Mesh instead of this one, instead of just a single one? And then we come to the idea of multiple interconnected Dapr-Meshes. And here I'm using a high level of abstraction where we hide the details of the individual services and we just focus on the meshes themselves. And here you can see Dapr-Mesh number 1 is doing a broadcast of an event, a notification of event, or publishing an event that 3 other meshes are listening to. And so what emerges out of here is a concept of, okay, now we have a mesh of meshes. Are things getting too complex? Probably not, because it's decreasing the complexity. Within each mesh, we've got complexity that we can control. And now we can really see the clear relationship between the big chunks of our system. And so the third reason to think outside the mesh is to think of each Dapr-Mesh itself as a higher order building block that creates a mesh of meshes. So just as we compose Dapr-Meshes themselves from services and components, we can also compose meshes of Dapr-Meshes from Dapr-Meshes themselves and any specialized components that they might have. And so this approach maintains Dapper's excellent separation of concerns, its component orientation, because the Dapr-Mesh itself becomes a component, and Dapper's inherent composability. Also, consider that a specific Dapr-Mesh component can be reused in multiple places in the software system. For instance, on an IoT system on a wind farm where there's, a bunch of windmills here and a bunch of windmills there, a bunch of windmills over on the North Ridge. Each one of those might have a field gateway that would have the exactly same Dapr-Mesh component in it that would monitor the windmills and, consolidate data and ship it up to the cloud. So this gives us a kind of an idea that Dapr can be a key part of systems that are much larger than just on a single local host or even a single Kubernetes cluster. So if we take a look at our previous logical diagram of our sample code down here in the lower left, the simple little 4 boxes connected by arrows, and we put that into a Dapr-Mesh. Here's what it looks like. We've still got service A, service B, and we've got a test client, and we've got a pub sub that's really hidden from the services themselves, but the sidecars know about them because they load the pub sub worker when the Dapr sidecar initiates or initializes. And so it's pretty much the same. This one's more cluttered though, whereas the logical diagram's cleaner and lets you focus on other things. So what happens if we took this here, all running on the same machine, this Dapr-Mesh, our own personal little Dapr-Mesh here, and we said, okay, let's put sidecar B and service B on another machine. What is that going to look like? Well, there it is. I didn't realize it at that time when I was running it like this the first time I ran it, but I thought about it later and I said, gee, I have 2 Dapr-Meshes. And so this also requires no code changes, which is rather amazing when you think about the number of components and things that are going on in software to make all this happen, that we can just take one chunk and plop it over on another machine, receive messages from a cloud pub sub. So I've noticed over the past few months that geographically separated services are a recurring topic on Dapr Discord. People occasionally say, we want to run a service on a VM at the edge or on-prem and communicate with our cloud mesh. Needs 2 Dapr-Meshes. And then the IoT scenario, like I talked about previously, it would require multiple Dapr-Meshes as well. So then we start thinking about how do Dapr-Meshes communicate, how do meshes of meshes communicate with each other. And there comes in the idea of the trans Dapr-Mesh gateway, which is a component of a Dapr-Mesh, a higher order component. And so what it needs to do is at least 3 things listed here: service discovery, so it knows how to send messages to other Dapr-Meshes, since that's beyond the range of DNS. And it knows also how to receive messages and dispatch them to the proper local service. And then finally, since this is probably going over the public internet, we need to have really solid security, probably above that we see on a Kubernetes cluster, including message encryption, because it's going to be stopping at who knows where, and maybe some router has been compromised by some bad guy or attacker. So thinking about that, so today, just with what we have, we can write a trans Dapr-Mesh gateway and a gRPC service, and you'll see an example of that. This is now in the code. In the future, we're going to need to have the trans Dapr-Mesh gateway be a component. So here we see it not broken out as separate. It's just part of the whole Dapr-Mesh idea. So that's the end of the concepts. Now the code sample itself is pretty straightforward. It's gRPC services in ASP.NET Core using Azure Service Bus Topic and Dapper. There's no business logic. There's no DTOs. It's really simple. It's just a code skeleton to prove the concept. It also has a load tester test client that I use quite a bit, and that can just pump messages through this thing like it's going out of style. And I've posted a sample of the code on this GitHub repo, and I will put the PowerPoint slide there up there too. And the install me instructions and read me document is not done yet. I'll get them done in the next couple days. One thing to note though is this sample uses the Dapper Slim installation that doesn't have any dependencies on other things. So now let's go look at Visual Studio, and should I enlarge the screen a little bit?
I think this is fine.
Okay, so looking over to the right-hand side, we see just a normal Visual Studio setup here where we've got service A and service B and the test client down here. And so let's look at the test client first. It's really simple. So basically all it does, it just goes into a loop and it accepts two kinds of commands. Well, a basic functional test. It talks to service A over gRPC. And then here's the test command where we can publish one event. Here's an example. We can publish multiple events, and all we do is add some timing. Publish 100 events at 20 milliseconds delay between each. The actual work is done here just by publishing event here using just a gRPC proxy. No magic. Service A is even simpler. Here, there's one receiver of events, or publisher of events, rather, and it just will wait for this method here, which publishes event async using the Dapr.NET client. And that requires a pub subname, a topic name, and an event payload. And that's it. Service B is a little more complex. Basically, in the .NET SDK, first Dapper, when Dapper loads, it will ask each service to say, list all of your topic of subscriptions, and it'll list, here's one topic of subscription, here's another topic of subscription. It puts them into a collection and then returns that collection. So here it's adding. And then it has, for each topic, it's got a receiver that receives events for all topics. And then I use a case statement to request to switch on the topic. And here's our topic, and all it does is just basically process the event. So the key thing to look at here in terms of a trans Dapr-Mesh gateway is that we could process the event locally in just a method in this service. This is service B. So we could go down here and process it and have a little event handler down here that does something. And or what we could do, one of the ways to process event is to invoke a gRPC method or a service invocation. In other words, we say, okay, we're going to map this event to a specific service invocation on the local mesh of the receiver. And so this is where or how you can make a Dapr-Mesh trans Dapr-Mesh gateway today on your own desktop system just by invoking methods in your local mesh. So that pretty much covers it. I can give you a demo run if you want to see it, or stop now.
Thank you very much, George. We're a little bit over time. Thanks for this. There is a question from Mr. Jenks in the chat. And he asks, how do you differentiate between the two service A instances? Because I think your diagram at one point showed two instances of service A.
Okay, how am I differentiating between what? Service A and service B?
Yeah, I just showed a. Yeah, so I think you had a slide here where you showed two service A instances.
Yeah.
Maybe in two different Dapper meshes.
So
Yeah, I think it's this one, maybe.
is that it?
Yeah, Mr. Jenks says this is the slide.
Oh, I see. I have this mislabeled. Sorry, that should be service B. A bug.
Okay, all right.
So I will change that. Good
Yeah,
eye.
and all right, thanks, Mr. Jenks, and thanks, George, for the clarification. One thing you might be interested in, and other people on the call, we currently have two outstanding PRs that might make their way into the 1.2 release. One of them is a general purpose DNS resolution and a console service discovery implementation, which will actually help with service to service discovery for scenarios like geographically separate services. And you'll be able to connect like two separate Dapper meshes, as you refer to them, into different clusters using this console service discovery mechanism. So that might be interesting. Might want to keep an eye out for that for 1.2. Thank you very much, George, for this presentation.
Yeah, thank you.
Yeah, and now we will give the floor to Maxime Kim from Microsoft, who's going to talk to us about Dapper and Azure API management for the second time. With Max, I will make you a co-host. All right, you should be able to unmute yourself now and share your screen.
Hello?
Yes, we can hear you.
Okay, and can you see my screen?
Indeed.
Okay, perfect. So my name is Maxim. I'm software engineer in Azure API management team. We are running service in Azure, and last, I think, fall, that was community stand-up, I think 23. We talked, me and my colleague Vlad talked about a preview of Azure API management, a self-hosted gateway feature integration with Dapper. And if you're not familiar with what Azure API management is and how it and what is API management self-hosted gateway and how it integrates with Dapper, I encourage you to go and see that recording of that previous community stand-up where it discovered. So I'm not gonna spend time on this today, and instead I'm gonna directly jump into demo of the integration features that we have. So last time they were in preview. Today they all made it to the stable version of Azure API Management Self-Hosted Gateway Docker image. And fortunately, Dapper itself made it to a stable major version. So today I'm going to demo them, both stable versions together. So for my demo, I have a AKS cluster. So it's managed Kubernetes in Azure with the Dapper 1.0 installed on it. And so for the purpose of the demo, I'm gonna use one of the gRPC applications from Dapper samples registry. It's very simple Echo gRPC application. and I'm going to deploy it on my cluster. So this is the deployment, very simple, and it's of course Dapperized. I'm going to deploy it to my cluster to this special namespace. And we see it is running. And next to it, I'm going to deploy Azure API Management Self-Hosted Gateway. So latest stable version of publicly available image. It has a couple of configuration parameters. This is configuration, the configuration endpoint that this self-hosted gateway is going to use to connect to the cloud and get the configuration, and the secret that is used to authenticate against this endpoint. And the gateway itself is also Dapperized. And I already have Azure API Management instance in the cloud that has this self-hosted gateway pre-created. So once I deploy the image, it's going to run self-hosted gateway and connect to this cloud Azure API Management instance, and going to use its configuration. So I'm going to deploy this one as well. And while it is getting deployed, I'm going to go and create API facade to use in this demo. So let's create a demo API. Let's leave the backend URI empty and define it later, and create one operation. Let's pretend this is API for managing orders, and it is going to have one operation to create an orders using post. Okay, so our self-hosted gateway is running. There are two containers. One is the gateway, another is the Dapper sidecar. So I also have a load balancer type Kubernetes service that's going to expose my gateway on the public IP. So now I can go and check that my self-hosted gateway is up and running. And now I can go and actually call this API that we defined here using Azure Portal. And let me just disable authentication for the purpose of this demo and expose this API to this self-hosted gateway. So let's give it a couple of seconds to propagate. So we get 500, and the reason for that is because this API is not configured to forward traffic anywhere. So since we previously deployed Echo gRPC service, I will show you how to make this self-hosted gateway deployment to actually forward traffic to this service. And API management by itself doesn't support gRPC, and I mentioned that this Echo service is gRPC, but thanks to Dapper, it's very easy to integrate them both, because Dapper infrastructure are going to take care of translating one protocol into another. So self-hosted gateway going to talk to its own sidecar using HTTP, and that sidecar going to communicate with the Echo service over gRPC. So in order to make it actually call this Echo app, Echo service, one thing we need to add to configuration is a policy, because every customization of the HTTP traffic processing in API management happens using policy, and Dapper integration is also implemented as a set of policies. So this policy is used for service-to-service invocation. So what it says is that for as a backend for this API or for this operation, we're going to use Dapper sidecar, and we're going to forward traffic to the application with the name Echo service, and going to invoke Echo method on it. So you can see that echo service Dapper app ID is declared as echo-service. And in the source code, you can also see that echo is the only path this service is listening on. So by defining a Dapper method as echo, we're going to invoke exactly that path. So now I can go and make a call again. Now we get 200 and get back exactly the same payload as we submitted. So if I change the quantity, it changes here as well. So that was working even in preview version. So one thing that changed with Dapper 1.0 is that cross namespace service-to-service invocation became available. And we added support for this feature in API management self-hosted gateway. So if I gonna delete my echo service deployment, and create another namespace, and gonna redeploy my echo service to this namespace. So we don't have this echo service in our original namespace, but we have it here. So if we try to call, we're gonna get error from Dapper, and this is just raw error exposed from the Dapper sidecar, probably not something you wanna do in real life application. So self-hosted gateway doesn't know, doesn't properly forward traffic to the echo service because it's in the different namespace. So to make it work, you just need to add one more attribute called Dapper namespace and define it as call echo. So now when it's saved, we're gonna try to make a call again and see that now we can reach service in a different namespace. Okay, so now let's pretend that this API actually creates order, and in response it returns order ID. So I'm gonna drop another set header policy that's gonna add response header with order ID. That's gonna be just unique ID of the request. And if I make call again, we will see that we are getting this order ID back, and every request is a unique order ID. So now let's imagine, in addition to creating orders, we're going to drop the message to a message broker to notify other microservices in this cluster and that order is created. So it's very convenient to do with Dapper and its pops up abstraction. And I'm going to show how you can make Azure API Management self-hosted gateway to act as a publisher of a Dapper pops up component. So I have Dapper pops up deployed on this cluster. So it's called demo pops up, and it is backed by Redis. So very simple Redis server deployment, as well as pops up of version 1. You can see it here. This is version 1 of the Dapper. So in order to make self-hosted gateway to act as a publisher for this pops up, we need to drop another policy called publish to Dapper. And configuration is pretty self-descriptive. It defines what is the pops up name, what is the name of the topic, and describes the actual data that we're going to submit. So for the purpose of the demo, we're going to submit just string called order created, colon, and the request ID, which is the same as order ID. So I'm going to save this, and now I can make a call again. Nothing changes from the caller perspective. But what happens underneath is, so self-hosted gateway is, in addition to calling echo service, also calls Dapper pops up using, through its own sidecar. So in order to show that it works, I'm going to run another pod with a Redis client. And I'm going to connect to this Redis server. And since Dapper pops up on Redis is implemented on top of Redis streams, I'm going to subscribe to the stream called orders and see what happens if I submit request. So I make a request, and I see that immediately the message is submitted into this Redis stream, and the message content here is order created and is a request GUID ending with 7CFF, and this is exactly what we have here. So if I block on the stream again and send another message, we see that another order is submitted. So this is how a self-hosted gateway can work with PubSub. And the last thing, let's imagine that in addition to publishing the message to the broker, we want to keep track of last created order ID in some persistent store. And Dapper provides another excellent abstraction to work with persistent stores called binding. And self-hosted gateway has another policy to integrate with Dapper binding, and it's called Invoked Dapper binding. So I added another policy that says we need to invoke create operation on the binding with the name demo binding. And since it's Redis, since it's binding back by Redis, we need to provide metadata key as a metadata, and I'm going to use last order ID, and the data itself is going to be request ID. So I'm going to save this. Demo binding is another Dapper component deployed on the cluster, backed by very same Redis instance. The same Redis server acts as a PubSub and binding. So this is binding configuration. Again, a very naive, very small. So I'm gonna make a call right now. And again, nothing happens from caller perspective. But if I try to get the Redis here with the name last order ID, I'm gonna see that the key is the ID of the order that was last created. So if I invoke it again, we see that key, it changes. And I think this is all I have for today. So this is, again, Azure API Management Self-Hosted Gateway, latest stable version integrated with the latest version of Dapper, and allows to do service-to-service invocation, PubSub, and binding invocation on a cluster, on a Kubernetes cluster. I think I'm done.
Okay, thank you, Maxim. This is great. This is a really good way to manage Dapper APIs and expose them also publicly. There's a bunch of Dapper security features like API tokens, both for authenticating the app and authenticating from Dapper to the app, and scopes that you can use to really take advantage of Dapper APIs being externally visible to callers, even outside of the cluster. And Azure API management in self-hosted mode really helps that when you're hosting on Kubernetes clusters. Thank you for this, Maxim.
Sure.
So you can stop sharing, and I will share my screen. Let me know when you can see it.
Yeah, we see it.
All right. So let's talk a little bit about the Cncf donation proposal. 5 days ago, we opened the PR. Mark Fussell, who's a Dapper maintainer, also opened this PR on the Cncf TOC repository for donating Dapper to the Cncf as an incubation project. And we're going to talk about what that means in just a sec. If you remember, when the Dapper project was launched in October of 2019, we said from the start that it's our intention to donate Dapper to a vendor-neutral foundation. This is, of course, to be inclusive for developer audiences running on all platforms, all clouds, on premises, and really attract more audience and cloud native developers to the Dapper project. projects, both as users and committers to the project. And this was done 5 days ago using this proposal. And what the incubation project here means is that Dapper is slated to become an incubation project. This is the maturity level that we, the Dapper maintainers, think that Dapper is at. If we look at the CNCF project, it defines a few, 3 maturity levels. Sandbox, which is really where actually all projects up until today hit the first time they're going into CNCF, and that's really the beginning of the chasm, really the innovator stage, before there's even early adopters. Projects at Sandbox usually build their communities there, implement things like CI/CD patterns, versioning schemes, other things like that, and then at some point, if they're ready, then they graduate to the incubating stage, where there's already early adopters of the project. And finally, there's graduated projects. There's pretty much a handful of these today if you compare it to the number of projects that you find in incubating or Sandbox. Those actually comprise of what the CNCF calls the late majority, the adopters who really take the technology after it's been proven and hit a bunch of milestones. And by examining Dapper and where it is today, we believe that it's at the incubating stage. Now, here's a bunch of projects that are currently incubating. Notably, you'll find gRPC, which is still in the incubating stage, Linkerd, Nats, Open Tracing, and Spiffy. A lot of projects that Dapper itself has a lot of integrations with. So Dapper, we believe, has the required maturity level to make it into here. And the TOC, the Technical Oversight Committee of the CNCF, will conduct a review and they will decide. It's important to note that if the TOC decides that Dapper's maturity level is Sandbox, we will happily go to Sandbox. So this is not going to be a blocker for Dapper going into CNCF. All the details of the proposal can be found here. So github.com/CNCFTOC, poll 6117. 617, and if you look at the file itself, you will basically see the proposal. We were currently assigned into a ZIG. A ZIG is a special interest group in CNCF. So they're special interest group for things like networking and runtimes and application delivery and workflows. We've been assigned into app delivery for now. You can go ahead and look at other projects that the special interest group for app delivery contains, but this might change in the future. So this is it. If anyone has any questions, or Mark or Ori, if you want to chime in.
No, I think you covered it pretty well. I'm not sure Mark can unmute because I'm not sure he's a co-host, but
oh, let me make him a co-host. Yeah,
he really kind of authored this proposal, so he probably has more to say.
Yeah, no, I think, can you hear me?
Yeah.
Yeah, we can.
Yeah, no, I think you covered everything very nicely. I mean, this is pretty exciting just because, the whole goal of this is that we aspire to get Dapper to be vendor neutral, to really build strong community, have collaboration across this, and it kind of directly goes towards, our commitment to go down that direction. So, please spread the word and make sure that, you kind of put your thoughts into this as well. We're excited to kind of make sure that we take this way beyond just kind of one small group of people to as broadly as we can, which is why taking it to CNCF is very crucial for us.
Yep, thank you. Are there any questions about the CNCF proposal? I think it's pretty straightforward, but if anyone has any questions, we can take them now.
Maybe one thing to kind of put a little context to it. I think hopefully some of you have seen that about like 6 months ago, we did put like a blog about our intent to kind of have open governance and our commitment to openness. So this is part of that journey, right? Like this is not like out of the blue. It's always been a mission for Dapper. I think we reinforced that message when part of the release announcement of version 1.0. So this has been a long time coming. We know some community members have also been kind of commenting on it. We've had some good partnerships with Alibaba that are also very active in CNCF. and are sponsoring our requests. So this is really kind of like a very natural thing, and we've been kind of marching toward that path for a while.
Indeed. Okay, so let's move on to the last item on the agenda today. Ori, you can share your screen.
Yes, can you see it?
Indeed.
Yeah, so I'll very quickly share some insights, some data. I've been tracking a little bit of the GitHub public data and some other stuff. And now that we're about 5 weeks out of the version 1.0 release, I know I shared a few things when we were like fresh after the release. It was just a few days, but now we have a little bit more perspective. And I want to share a few things. Hopefully you can see this, but this is a little bit about the community kind of growth and health. Overall, maybe we should start with stars. I don't know if you noticed, but we're really coming close to like 12,000 stars at this point in time. And if you see, this is kind of like GitHub kind of tracks the event of somebody starring a repo. This is just for Dapper, right? We got stars. There's a bunch of repos for Dapper, but really the big one is Dapper in terms of stars. And you can see that huge bump right when we announced version 1.0, which was February 17th. And it's really cool to see. This is like a great indicator to see that people were checking out the GitHub repo and kind of wanted to keep an eye on it. I think what is also really cool is that even though that kind of went down, because that's how these things go after release, it did kind of bump up the baseline, right? So we are getting more people coming in and looking at the repo, and we're going to see some more evidence of that in the next slide. But basically, this is kind of like a good indicator that we did make an impact and a splash and got a lot of eyeballs on Dapper, which is great to see. But really, I think one of the things we really care about in the end, and that's not necessarily something we can still see the result of the release is, but that definitely has an effect, is the number of contributors we're seeing coming into the project and how the community itself is growing. Now, just for kind of to be a little more exact about it, the thing that we define as a contributor is not just code commits. We speaking of CNCF, like we just talked about CNCF, we are trying to map to their definition of a contributor, and they have this definition. You can see it in their repos of anybody who is not only opening a PR and committing code, but also opening issues, commenting on issues, really engaging with the community. That is a contributor, and that is a contribution. So with that lens, we see that at the end of February, so this is like the last full month, we had like 759 contributors, which is pretty cool. And if we look at that growth over time, we're seeing really good steady growth of this community, which is great to see. I think we were like around, so we can see like we were under 700 in January. So we got 66 new contributors in February alone, which is, I think, a record per se. This graph also shows how many people are actually contributing per month. So 759 includes people that maybe made a commit like, in version, I don't know, 0.4 and never have shown their face in the community again. But we're actually seeing a lot of people, 140 people contributed in February, right? Out of them, about half were new people. So I think that's really a healthy indication of where we are at with the community. And I mean, I think this is also interesting to see. Obviously, the first place people, the main place where people are contributing is Dapper. That shows that the significant chunk of it is people contributing to the code. Obviously, docs is another huge place, and people are helping us make the docs better. As a docs maintainer, I can tell you, very much appreciating that and seeing a lot of PRs and even issues opened by the community, which is great. Components contrib, another huge way to help Dapper grow, just building that ecosystem of components. So these are really the things that we would expect and we see contributors kind of going into. But really across the board, we're seeing everything from the different SDKs and the CLI and so on. So this is really great to see. I think we're seeing a really healthy community. I think we'll try to add more of these kind of like updates moving forward. Not probably every call, but maybe once in a while. I think it would be cool to see the trend here. Another cool thing to look at, something you can see, and that's public information from Docker Hub. You can see how many people are pulling the Dapr.io Dapr-D image. And if you think about it, this happens not necessarily when you're running it in self-hosting mode, but really when you're deploying this to Kubernetes. So deploying to Kubernetes is a little bit more of kind of like a deeper engagement, I would say, with Dapper, even maybe using it for a POC or maybe in production even. And I think aside from this is probably like a measuring mistake, because I see there's like nothing here. So this is probably the addition of these 2 days. But we've had kind of like a consistent kind of baseline around like between 50 and 70,000 pulls per day. Again, seeing that bump of the release and then settling down on a new baseline, which is about 2x, which is again great to see. So we're basically seeing here a higher adoption, right, of Dapper, and a higher rate of deployment of Dapper into Kubernetes services. So I think this is also a great indicator to see. And just lastly, another kind of way of bump is across our kind of websites, the docs, the main website, Dapr.io, and the blog. We're all seeing like these bumps during the release, and again settling down on a really nice new baseline, which shows that there's a lasting effect here, and that kind of like increased awareness is translating to people being more engaged and working with Dapper, trying it out more. To me, the most important piece is the docs part. Even it's not just because I'm a docs maintainer, but also I think like these two, the blog and the website, are great for like, you know, creating awareness. If you're just new and you're like want to understand what Dapper is about or get up-to-date news, and well, the blog is really kind of like periodic, right? Whenever we have a nice blog post, there might be a jump, but that's kind of like moments in time. The docs is really where people come to do stuff, right? To read, get a deep dive into the technical things, or looking for how-tos to go and accomplish specific things. So I think this is really encouraging, and I'm really glad to see this. And really, just a big thank you to everybody on this call and to the whole community on just like helping us get to this point. I think we're seeing a very healthy community growing and expanding, and really looking forward to see how that continues in the future.
Thank you, Ori. So we're 2 minutes out. Any questions? Let's go into the open discussion now. Didn't get a whole lot of time left for open discussion this time. Thanks everyone for the comments. So if anyone wants to unmute, please write to us in the chat, or just ask your question in the chat. Okay, there is a question. I'm reading it. I know that RabbitMQ feature support is now in alpha stage. Is there a plan for additional features to the respective pub sub and binding components? So do you mean for RabbitMQ specifically, or to pub sub as a building block? For RabbitMQ, you'll need to check in the components contrib repository. I don't remember off the top of my head if there's any specific issues to extend the pub sub component. If you want some, the best thing to do would be to open an issue, and then either a maintainer or a community contributor can pick those up. But nothing that comes to mind for RabbitMQ currently. There's been a bunch of PRs actually to RabbitMQ, I think in the past 2 months, but nothing new that I can think of. Question from Kai: any update whether Alibaba Cloud is going to contribute components for on-primitive?
Yeah, I can take this one.
Yes, Mark.
Yeah, the answer to that is yes. We've been doing, you may have seen that we published earlier this week a blog post about Alibaba and how they've been using Dapper. If you go and visit the Dapper blog, and maybe Ari can pop that in the chat window here, you'll see that they're very actively engaged with us, and they are using Dapper quite heavily inside their infrastructure. And we are working closely with them to publish a number of their different components. They'll include storage components, pub sub components, in about the next few months. You know, they've actually just been testing them all and installing themselves. So expect to see something within the next couple of months on that, and we'll share something a bit more then. And we'll hopefully get them on a call as well. It's a little bit harder for them to do it at this time of the day. They tend, but we'll have to have a call at a different time of day to get them to come and talk about it. They listed it at the bottom of their blog post. Now I see it here. Now Ori's shown it on the screen. So yes, that's their intention to publish some of these things, and we're pretty excited about it.
Yeah, this is actually a really great blog post. I really encourage you to check it out. It really dives deeper into the different use cases and how they're using it, how they're kind of approaching Dapper as trying to validate it in there with their intentions. They're really going all in with Dapper, it seems, and that's awesome to see. We've seen a lot of really great contributions from them, and definitely, as the question kind of alludes to, the next step for them is absolutely to include some Alibaba Cloud services as components here, which is great to see. And I pasted the link in the chat if you want to check out the blog.
Yeah. So Hugumi asks, if we have time, could we discuss the job shutdown PR? So this is the end of the call. I am willing to stay on and talk about it if you want. The rest of you, feel free to leave or stay as you like. But sure, we can discuss this. Or just stop the recording.
No, we're still recording. We can. I'll stay on. That's
okay.
Good.
Cool.
Could be helpful.
So let me unmute you.
Yes. Yeah. Hello.
Hello.
Could you hear me?
Yes, we can.
Yes. So yeah, I've been working on a little pull request about the job and the job handling on sorry, on Kubernetes. So one of the biggest concern was about the sidecar not shutting down, because in a job every container has to be shut down at the end. So I've created a little pull request to add an endpoint to the shutdown. I can share my screen if you want a little demo.
Yeah, sure. Is this an additional PR to the one that you already opened?
No, it's the actual PR.
Okay.
I cannot share my screen. It says
yeah.
I cannot.
Hold on a sec.
Yeah.
Try now.
Yeah, should be good. So it's this one. Okay. So you should see my terminal.
Yep.
So I have Kubernetes with Dapper deployed, with my pair deployed. And I have two YAML that I will deploy, one with a basic job sleeping a little and without calling the new shutdown endpoint, and one job with the new endpoint call at the end of the job. And we're going to watch the behavior of those two pods. So the job creates pods. Pods are fed with a sidecar container and created. And the one without the shutdown will go into a specific state where only one container is running. And the one with shutdown should be completed if my work is working. So now the job is running, it will sleep for a little and then end the job. I'm gonna wait a little. Maybe I put a little too much sleep, but it's a heavy job, sleeping.
This is really great to see, by the way. I've wanted to get Dapper sidecars instead of Kubernetes jobs for very long now.
So here is the weird state. The one without shutdown will be not ready because Kubernetes thinks that one of the two containers is not running great, which is the job container, and the one that's running is the sidecar container. And the one with shutdown is actually completed because the two container has been shut down gracefully without any exit code. So yeah, this is my pair.
Okay, yeah, and like I mentioned to you on Discord today, we want to merge it for 1.1.
Okay.
So we just need to make sure that the docs PR and the Dapper PR are in place, and then we can merge the SDK additions for the endpoint during 1.2. That shouldn't be a problem.
Okay.
Yeah. So do you have anything else to ask? Because
No, yeah.
we looked at the PR. It looks good to us maintainers. So.
Okay.
Yeah.
Great. Thanks.
Thank you again for this. Really appreciate it. Okay, so we can, yeah, it is exciting, like people write in chat. Thank you, and we will now end the call. Thanks everyone for joining. Hope to see you here next time.
Thank you.
Thank you.